Hi, I'm Mitch Winger. Welcome to this video where we discuss data mining and how we can use it to help solve business problems. Hope you enjoy. Data mining can be considered a process. The CRISP DM methodology gives us a good approach with well-defined stages. And depending on the stage, we may use technology, but some stages actually focus more on our creativity, our domain knowledge, our common sense, and just the way we approach problems. We'll dive in to the CRISP DM methodology in some level of detail in another video in this series. In the meantime, let's get into a little bit of how we tackle business problems using our data mining activities. So in general, once we have identified that we have a business problem, or we have some notion that we have a business problem that we'd like to solve, we've got a number of different categories of tasks that we can apply to it. The first one is classification, or we may also call this class probability estimation. So we're basically trying to decide which category, which classification each instance belongs to. Will they buy? Are they likely to buy? Are they likely not to buy? Which ones are more likely to respond to an offer? Which ones may have a positive outcome for a medical test? All right. And we'll get into the positives and negatives as we progress in this class. In data mining and these types of tests, sometimes a positive outcome isn't what we're looking for. So classification, class probability. The next one is regression. And in this case, we're estimating a value. And this is something we see when we look at trend lines. We're basically using some kind of a regression approach to maybe predict what the next value will be. So regression ends up with a numeric value prediction. Similarity matching. So in this case, we're trying to figure out which individual or which instances of data may be similar to other instances based on what we know about them. Clustering. In this case, we're basically trying to group individuals based on similarities and on differences. We want clusters that are more similar to each other for the people in the cluster and more different from people or instances in the cluster in other clusters. In this case, we don't necessarily have any specific purpose in mind. So we may have the question, do our customers form natural groups or segments that we can then investigate and try and find something useful about it? So a lot of times we'll use clustering in preliminary exploration, exploratory data analysis, or EDA. You'll see that term a lot. Co-occurrence grouping, and you'll hear this phrased a number of different ways depending on which industry or domain you're in. Association rule discovery is one way you'll hear it. Market basket analysis is another one, where if people buy one thing, what else are they likely to buy? So the whole Walmart hurricane thing falls into that category. So we're basically trying to look at different transactions involving entities, whether they be customers or companies or whatever, and figure out what gets lumped together. So it's a little bit different than similarity because the objects may not necessarily be all that similar, but they just end up being grouped together in the same transaction many times. Profiling. This is another one. We also call it behavior description. So in this case, we're basically trying to characterize typical behaviors of an individual, of a group, of a population. So what would the typical cell phone usage of this type of customer be, for example? And the behavior may not be that simple to describe, so it may have a real complex description of different types of activities over time, where, location usage, things like that, what kind of charges an individual is amenable to versus those they don't want, and so on and so forth. And profiling can also be used to help identify anomalies. Link prediction, well, here we're basically trying to predict connections between data items, suggesting that there maybe should be a link when there isn't one. One of the prime examples that comes into play there is LinkedIn or Facebook. You'll see oftentimes that because you have connections to these people and they have connections to other people, maybe you should have a connection to that other person as well. So this is, and there's a predictive strength of those anticipated links that comes into those predictions. Other techniques include data reduction. So in this case, you may have a data set with many attributes or measures or values, variables. So the idea is we want to see if we can replace the many attributes with maybe some smaller meta attributes that incorporate the information we have in those additional attributes, but reduce the amount of data that we have to analyze, the number of measures, the number of attributes that we have to analyze. We'll talk about that as we get in, but it's real similar to principal components analysis that you may have heard of or discussed in a stats class in the past. Causal modeling, in this case, we're basically looking to see, what events influence others. And causality is, since we're generally trying to find things from secondary data, we're always going to be kind of inferring causality or trying to imply causality rather than be able to provide support for it through some kind of an experimental treatment. So the idea here is we've got all these different kind of tasks, and we may, as we decompose the overall problem, find out that some of the subproblems incorporate different techniques. So we may use a variety of these techniques for a single business problem. Next, we have supervised versus unsupervised learning. So in unsupervised learning, we don't really have any target in mind. Like we want to get this will this customer purchase? Will this prospect purchase? Will this customer churn? We're usually exploring the data at this point in time. So we want to see, can we group transactions in meaningful ways? Do our customers fall into natural groups? What about our employees? Can we group our employees? The groupings, we need to keep in mind that groupings that we find may end up having no actionable meaning. So we may find some groupings, we may poke into them further and find out that, well, there's not really a whole lot we can do here. So then we move on. Supervised learning, on the other hand, we have a specific target. And the caveat there is that we also have to have existing data on that target. We need to have some existing results for that target. Will this customer leave once their contract is up? How much revenue can we expect from this potential customer? Is this transaction fraudulent or valid? So we need to have some existing data that we can use to train our model. So for the most part, we generally use clustering, co-occurrence grouping, profiling, those types of techniques, those types of exploratory techniques for unsupervised learning. This is not a hard and fast rule, but in general, you'll find this happens more than not. Whereas when we get into supervised learning, we'll use some of the techniques where we do have a target variable classification, regression, causal modeling, etc. So when we do our mining, we end up having two distinct processes. And we oftentimes start out with unsupervised learning, and then we can start finding some things out and developing, maturing in our approach. And so we end up spending a fair amount of time developing the model itself. We're using historical data. We're using exploratory techniques. We're using predictive techniques to see if we can come up with something that helps us in business decisions. And at a certain point in time, we say, okay, we've got a model that's going to work for us. Let's move forward with it. And at that point, we put the model into use. So we're going to apply that model. We're going to put it into some kind of an existing business process using some code or using some tool that allows us to call for results for a particular transaction. And we apply this model to new data that we haven't seen before. And we make a decision on this new data. Will we issue this person and approve a new credit card for them? Will we approve this loan? Will we offer a discount for a new phone contract, etc.? And in the best machine learning situations, you have a model that can incorporate new decisions made by your population and have the model update itself. So from a managerial standpoint, well, a lot of managers that you'll find out there, and managers even in your firm, are already familiar with software projects. They may have lived through the big wave of ERP implementations, new CRMs, customer relationship management systems, supply chain implementations, things like that. So they understand how software projects work. And unfortunately, that does not always translate well to a data mining, data analytics project. Okay? In a software project, you've got pretty set milestones that can be agreed upon ahead of time. Success factors are usually fairly easy to figure out. They're unambiguous. There's no, questioning what's going to happen. Data mining, as we just mentioned, there's a lot more exploration in the process. And as we'll get into when we start looking at CRISP-DM, we'll find that it's a lot more iterative with maybe some false starts and dead ends that we have in there. So it's not necessarily a straight line beginning to end type process. It's more of an R&D type process than an engineering process, because you're going to find, again, sometimes you have these dead ends. R&D, the best companies have a lot of R&D projects that end up going nowhere, but they have enough of them going on that some of them end up panning out. And the same kind of concept here. So the CRISP cycle is, based on exploration, a lot of iteration, a lot of moving back and forth between phases and so forth, and focusing more on strategy than on the software design itself. We don't have certain outcomes, and results in one step may actually change the fundamental nature of the project in general and have you kind of reformulate the problem from scratch. So we eventually get to a point where we do have something measurable for these business processes, but the skills required in data exploration, data analytics are not as easy to measure as maybe programming, lines of code, things like that. So being able to identify and evaluate ill-defined problems and build something meaningful around them, a person's creativity, the ability to quickly develop reasonable assumptions, develop quick prototypes. So we may have more of an affinity to agile software approaches than we do your standard software development projects. Being able to put together high quality tests, analyze those models, analyze solutions appropriately. So I've kind of walked you through all of these bullet points here, and they're important to keep in mind that right now CRISP-DM projects are a lot different than software projects. And of course, when we're dealing with data mining and data analytics, we've got a lot of different techniques and technologies. We're going to be focusing on machine learning and data mining in this particular course, but you're certainly relying on information in your other courses as well. Descriptive and summary statistics, these are the kind of the stats that your general business person may ask for, versus the real statistics or the more in-depth statistics that we rely on in data mining. Advanced stats, hypothesis testing, hypothesis generation. So correlations and covariances, things like that come into play. Database queries, being able to pull the data, massage it, and prep it appropriately using SQL tools like that is an important additional skill set. And of course, the data warehouses that become a facilitating technology, and as we're seeing more and more, maybe not necessarily a necessary step, as some companies are moving toward pulling data directly out of their data lake, or maybe even directly from their transactional systems into their analytical platforms. And then OLAP queries using MDX and things like that. So all of these other technologies come into play as well. So we're at the stage now where we can consider data analytics to be relatively structured, yet quite creative as a craft. So we're building structure with a methodology, but we need to be curious, creative, and insightful in how we develop solutions. In addition, you may have to help with expectation setting regarding data analytics projects with your management or with your client's management. Results are not guaranteed. You can't go in there and say, well, we predict, you're going to be able to streamline processes this percent, like you can with business process re-engineering and ERPs. So there may be, and you also have to let them know there may be several or many false starts along the way. Nevertheless, organizations are finding ways to effectively utilize data analytics and analytics techniques in more and more areas of operation. So the cat's out of the bag. We're seeing a lot of organizations go mainstream with data analytics, and you're going to be playing right along with them. So that's it for this presentation. I hope you found it informative, and we'll see you next time.